So let's have some fun with this. Let's have some fun. What questions do you have? Process questions. Process questions. What process questions do you have? Yes?
I can find the intercepts and all of the asymptotes, but I don't know how to graph.
But I can't graph them. Okay. Anything else? Any other process questions that you ran into? Any other process questions? Yep. Yeah, go ahead. Pass. Okay. Pass. Yeah.
What is?
Yeah.
Is it necessary that every graph you should figure out is if there is a crossing, if there's an intersect of the graph and the horizontal asymptotes?
Yes.
Is it necessary for every?
To check. Check to see if the graph crosses HA or OA. Yes. Other questions, and we'll answer them all. Yeah.
Yeah, I don't understand what the horizontal asymptote actually does. Like, I don't know
what does the HA do mean? Yep. Okay. What else? Baldwin, and then over there. If you found it, you know what it is. That's what we did yesterday, the division. Okay. Okay. Wow. How do I know where the OA is? Okay. What else? Yeah.
If we have a horizontal asymptote, can we have an oblique asymptote?
What?
Can we have both?
If we have can we have an OA? Okay, so let's answer some of these by directly answering, and then some by process. Can find intercepts, but I can't graph them. We'll practice this. Pass. Okay, we're going to pass on pass. Is it necessary to check to see if the graph crosses H? Yes, it is. It is. What does a horizontal asymptote do? We'll see one. How do I know where the oblique asymptote is? Run the polynomial long division. That's what we spent all day yesterday doing, finding oblique asymptotes. If we have an HA, can we have an OA? What do you think? No. Can only have one or the other or neither. So let's do an example.
When it asks for
Yep.
the intersection, so it wants to know where the
function
graph of the function is intersecting with the
oblique or horizontal.
So we only need to run the polynomial long division when we see that there's 1 degree.
When the degree on the in the numerator is 1 greater than the degree in the denominator. That's correct. Okay, so which one do you want to talk about? Which one do you have specific questions on that you think we should cover? Which one? Justin, which one?
R5.
You just want to go straight to R5?
Yeah.
That was the hardest one? Yeah, definitely was the hardest one. Can you show me R5, Linus? Let me just copy it down here. Which one is it? So that's x cubed plus 2x squared minus 5x minus 6.
Over x cubed plus 7x squared plus 7x.
Oh, and before we go on to this, what did you guys think of the video last night? Was it decent? Looks like we don't have too many, no outliers there.
The rational 5 one.
Yeah, rational 5. The one that says rational 5 on the board. Yeah. What did you think? Was it helpful? Am I keeping them the right length?
Yeah.
Is that better? Just keep, if it's when just you get it, and then how many people are rewatching it? Anybody rewatching it?
I rewatched this one.
You watched this one? Okay. I actually find myself rewatching it sometimes. It's weird listening to yourself, mainly because I'm captivated by it. I talk so much anyway. You'd think I'd be okay with it. Yeah. No, you're just scratching. Okay. So, what one immediate observation can you? What's one conclusion or what's one thing you could tell me right now about this, just by looking at it, without doing any math? Yeah. Yes. And what is it?
It's 1.
Y equals 1 is the horizontal. Do not say 1. That's like saying what's your favorite color? 58, because that's the spectrum of the the light wavelength. It accurately describes it, but you need that y equals. It's really important. So yes, it has a horizontal. So what does that mean? If it has a horizontal, no oblique asymptote. Yep, exactly. So at this point, what are you going to need to do? What are we programming? What am I trying to program you to always do first? Simplify. And by simplify, we need to Factor! We love to factor. Who has the numerator? Who wants to go out and tell me what the factored form of the numerator is? Stanislaus. Yep. Yep. Who agrees with that? Who agrees with that? Raise your hand. Do you agree with this or not? The order, yeah, the order's fine. Good, okay, you're popular. Yay! You've always wanted to be popular, right? Okay. Denominator. Who has the denominator? Justin, what is it?
X minus 1, parenthesis times, parenthesis x plus 3, parenthesis times x plus 1.
Who agrees with the denominator? All right, you're popular too. All right. So at this point, what do we need to ask ourselves? What is the domain? And let's use random people today. I miss using random people. I don't do that enough anymore. Let's randomize this. Justin, look at that. What's the domain?
Domain is x cannot be
X such that X
such that x doesn't equal 1, -3, and -1.
And -5. That is correct. Yay. So now we look at the intercepts. When x is 0, what's y? What? 6/15, which is 2/5. That is the y-intercept. How many x-intercepts are there? 2, because this cancels, leaving you with, there's going to be one at -1 something and, well, actually we know what that something is. What is it? -1, 0, and 2, 0. Exactly. If I said, is this a 0? No, because it's the function defined at -3. Look at the domain. X can't be -3, so is the function defined at -3? No. Just always check your domain. What's the next thing we like to check? Symmetry. What do we think about symmetry? Neither. Are you going to see a lot of neithers on these? Yeah. It's mainly going to be an exception to the rule. When it is symmetric, it makes your life easier, but it's not going to happen that often. Sorry. Symmetry. Vertical asymptotes. Let's go with Steven.
I have it at -1 and -5.
1 and -5, actually. What makes the denominator 0? 1.
1, yes.
Right? Close. Very close. Removable discontinuity. How many are there?
1.
And it occurs at what x value?
-3, -5 over 4.
Negative what? Is that what you get when you plug it in?
Yeah.
Okay, I'll go with it. Cool. So now, we've done DIS, VARD, HACOA, and we've already done horizontal and the oblique, right? We did that first. Great, so what's the only thing left? Crossing. So how do we, well, we know our horizontal asymptote is y equals 1, right? So we take this, if we want to know where it intersects, how do you find out where two things intersect? You set them equal to each other, exactly. So if we take this and set it equal to 1, what do you do next in order to try to solve this? You multiply both sides by something. Nope. Yeah, cross multiply. Multiply by the denominator, right, Allie? So you get x cubed plus 2x squared minus 5x minus 6 is equal to x cubed plus 7x squared plus 7x minus... what cancels?
X cubed.
Woo! Now what do we do? Combine like terms. Let's put everything over on the right. So you end up with 0 equals how many x squareds? 5x squared plus what?
12x minus 9.
Minus 9. That's a quadratic. How many possible solutions could that have? It could have 2, 1, or none. Could have 2 imaginary. Could have 2 imaginary, 0 solution. 2 imaginary, 1 real, or 2 real. How do we go about solving this quadratic? Well, we hope it's what? Does it look factorable? Does it look?
It is factorable.
It is? Oh, nice. I set up a good one. So what is it? Can someone tell? Yep.
5x minus 3.
Yep.
Times x plus 1.
That works?
Yes.
Look at that. Oh, wow, I set it up. So what does x equal?
X equals 3 over 5 or
-3. Now here's the thing. Here's the thing. Is -3 in our domain? No. -3 is not in our domain. -3 is a RD. So there's a removable discontinuity where this thing crosses the...
Yep. Yeah.
So, yeah, so we'll put it together. We'll see what this looks like in a second. But we need to be careful of because is -3 part of the domain? No. Is 3/5?
Yes.
Absolutely. So how would we go about finding out? We want to know the point at which it crosses, right? So it's 3/5, comma.
1.
What is it?
1.
1, because what line is it crossing? Y equals
1.
1. Exactly. So we know it crosses the HA at that point. So let's put this all together. What are our intercepts? Okay, -1 and 2. Again, are we looking for something that's super accurate? No. So we're at -1 and 2. And what was the y-intercept? You remember? 2/5. Looks vaguely like that. Do we have a vertical asymptote? 1 and -5. So let's do 1 and -5. Is it okay if I mess up the scale on this? Yeah, I'm just going to give myself the ability to do that. -5, yay. Yeah, it can't go down because there's no other x-intercepts. Right, so it has to go up. It has to go up. Exactly, nice. Okay, so what other this removable discontinuity, it has to get infinitely close to that, right? So what's it going to do? It's going to go down right here. Exactly. So we have the middle part of it. Ah, what about this 2? That 2 helps us a whole bunch, right? Use your hand. What's it going to look like? Whoop. Yeah, it's going to go like this. Does this ever cross the horizontal asymptote over here? No, we already proved it only crosses once. Where is that? Well, no, is it? I'm sorry, 3/5. Yes. The domain for this function is x can't be 1, -3, and -5. Yeah. So here's -3. There's -5, and there's 1. So it's not crossing those things. So the domain still holds. So what about the other side? What's the last thing we need to know about? This side, right? We need to know, is it above or below that green? Can someone tell me how we know for certain which one it is?
I think it's above.
It is above. Why? What is... Now this is the term I didn't bring up yesterday. What's the power of this term right here? We talked about this yesterday. That means the multiplicity. This is a new word for you. Multiplicity is odd. If the multiplicity is odd, what does that mean about the asymptote? Opposite directions, exactly. If the multiplicity was even, it would go in the same. But we know it goes in opposite directions, so therefore, where does the other side have to go? It has to go up, meaning it looks like this. If you were ever totally stuck, let's say you didn't know if it went up or down, what could you do? You could pick a number to the left of -5, and what could you do with that number? Plug it in and see where the point was, and see if it was above or below. Plug in -6, right? So,
my reason is,
yeah?
If it's below, then it's going to be another 0.
Exactly. That's another graph. Exactly. Because the only way for this to be below and not be for the axis to be a horizontal asymptote, do we have any other horizontal asymptotes? No, you can only have one, for the most part. So did we piece this together pretty well? Yeah. Can you hit the lights, Baldwin? Let's take a look at this closer.
I don't get the last part.
The last part is this. -5. You see that right there? Why do we have a vertical asymptote there? We have a vertical asymptote there because this right here. That right there. What is the power of x plus 5? 1. That's an odd number. If it's an odd number, the asymptotes have to go in different directions. The approach has to be in different directions. So if on one side it goes down, the other side it has to go up. What happens if it was x plus 5 squared? They'd both go up or... And the logic for that, I can explain it. It's a little bit tricky to understand, but think about it this way. Look at this whole function, okay? Look at that whole function. Think of numbers a little bit to the right of -5. So -4.9. What's -4.9 plus 5? Is that positive or negative? Positive. Think of a number to the left of -5, like -5.1. What's -5.1 plus 5?
Negative.
It's negative. So what happens as you go across -5? That term, this term right here, x plus 5. So let's look. I'll write that down. If we had x plus 5 right here, and you were looking at a number line right here, and here's -5, everything to the right, when you plug it in, would make this thing positive, and everything to the left would make it Negative. So the sign that piece contributes to the polynomial changes. So the sign instantaneously changes. So what does that mean about the direction of approach? Instead of approaching down, it's suddenly going to approach up. And if it was approaching down, it's going to flip it upside down. Does that kind of make sense? For values around -5, what's the only term that's really affecting this graph? The x plus 5. It takes a while to understand that, but you can think about it, okay? When you're in the neighborhood of -5, what's the only term in this rational function that matters, really? X plus 5, right? Because that's the one that changes sign. Do all the other ones around -5, do they change sign? Does x plus 1 change sign around -5? No, it's always going to be negative around -5. -5 plus 1, -5, -4.9 plus 1, it's always negative. That's a little bonus thing to think about. So what did you think of this? Yep.
I have a question for
Yes.
for the cross.
For the cross, yes?
Yeah, so, but when you're using the graph and you assume that the whole graph is...
Last thing you should do. Check your answer. Why do you check your answer? To see if it's right. And sometimes you've made a mistake and it's wrong, but sometimes you have answers that are not correct. Is it possible to generate extra answers? Yes, it is. Remember when you were square rooting things? We did this at the beginning of the class, I think. When you start squaring things, is it really easy to generate false answers? Yes. Justin, it's a false answer. Just because we did the math right doesn't mean that the answer is necessarily correct.
Oh.
Okay?
Okay.
That's why. Okay, good. You can generate, I'll put that in here, false answers. And what are you doing to combat false answers? Check your work. And also, there's another thing you need to check. Not only check your work, what else should you check? Please check reality, too. Just think about the answer. Does it make sense? Here's the thing that's going to drive you crazy. I'm just telling you this right now. What happens if you're cruising along and you're like, oh, but there also is a 0 right here. Let's say you put a 0 in the wrong place. What happens to putting together the graph if you have a 0 out of place? Is everything gonna did this fit together nicely? Pretty much, it fit together nicely, right? If we got a 0 wrong, what would happen to fitting it together? It screws the whole thing up. It's like missing a negative sign in the polynomial long division. What happens? So really, what do you need? Aw, man, the timing is off because I didn't turn it on. Aw, man. What do you need?
I mean, how silly is that? And we're talking about practice.
So practice. Practice. We already did. We already did. Web tool of the day. Just something that might help you in your academic endeavors. Here's the first thing I want to show you. Has anybody seen this site? It's pretty much brand new. It just launched on the 24th. Quickie. What it does, someone give me a person, or a place, or a thing.
Kennedy.
John Kennedy?
Is that a Wikipedia?
Yes, that's actually a really good way to. That's a good way to put it. Yes, it's a port, is what you could call it. There is wiki in it. And for some reason...
1963, in Dallas, Texas. Leonardo Oswald was charged with a crime but was shot and killed 2 days later by Jack Ruby before any trial. Caroline Bouvier Kennedy was born in 1957 and is the only surviving member of JFK's immediate family. John F. Kennedy.
Okay, so
born in 1960.
it works equally well with any Wikipedia entry, and it pulls out pictures. So if you ever need to look something up quickly and get a basic idea of where to start, this is a great tool. It was really neat.
Like the same length for everyone, or they
No, it depends. So they're going to work on. It's brand new. They're try having users contribute to improving it. But what's neat is it auto generates it. It auto pulls the images and it syncs the audio, and you can listen to it. It's pretty neat. It works really well. So if you want a good starting point, this is a great starting point. That's a good question. I don't know. No, that's a really good question. Wikipedia is widely known for like being in 200 million languages, or there's not 200 million languages, but many. I don't know if they're doing other languages, but I'm sure that's something they're either thinking about or it can do. You could try it. It's really neat. I found that the images and the reading and the text all at the same time. Great way to great overview. The sound, no, it's a computer reading it, and it's getting better. It's not bad. The second thing I want to show you is this. How many people have seen Wolfram Alpha before? Who's seen this before? Yeah, I want to show you some few things. Ready? So, for example, it can do simple things. It's a search engine, but they call it a computational knowledge engine. Enter what you want to calculate or know about. What's something you want to know about?
Anything?
Anything.
How much a polar bear weighs?
Oh, Thailand and...
How much does a polar bear weigh? No, it can be anything.
It's like an encyclopedia.
Yeah, but it does a little bit more than that. How much does a polar bear weigh? Look at this. It's gonna fill all this in. You see this? Okay, you like that? So how does that apply to this class? So it'll do that. You can ask it questions, and it'll come back with really neat answers. But watch this. This is what I want to show you.
Oh my, I love this thing.
Do you see what it just did for you? So let's go over what it just told you. It gave you the input. It showed you a nice graph. It showed you a graph from very far away. It told you what shape it is. It gave you 3 alternate forms. It gave you the roots. It gave you and then later when you take calculus, it gave you the derivative, the indefinite, the global min, the indefinite. And what's really neat about this, watch this. There's all these buttons over here on the right I was playing around with. It gives you more alternate forms. And then check this out for the calculus right here. Look what it does. Show steps. Boom. Written out. Pretty cool?
Can you copy the link to the...
I'll put the links in a document in the class webpage, okay?
Can we try this?
So we're throwing our polynomial at this. Check it out.
Oh,
Look what it just did. Gave you the input. Does this graph match right here? Does this graph match it?
little bit.
Oh, it does. Oh, look. Does it go up like that? Do you see it right there?
Oh,
It does it, right? And then it goes up.
small.
Yeah. Oh, wait. Does it match exactly what we did? Hold on.
Almost, yeah, it's
Oh, yeah, it does. Look, it does match exactly what we did. Look, did it factor it for you? And it not only factored it, what did it do? It canceled, right? Roots, derivatives, and some other fun stuff. So is this slightly useful if you want to check some work? Be cognizant of the tools that you can use. Make sure you know how to use them and make sure you know the math behind them. I think we could design an interesting curriculum where we just give you all the answers. We just give at the beginning of the class. Here are all the answers. Let's go from there. Let's eliminate thinking about looking in the back of the book. That'll solve your problems. No, it'll solve the problem, but it won't solve your problems. This is an online grapher where you can graph multiple functions and you can set your window, and it works rather well. I'm a big fan of it. It's a great way to generate graphs that you want to insert into things. So let's try one of these. So if we try one, so for example, we could also graph cosine x. Enter. There it is. Let's do tan x. Enter. So let's clear that. Let's clear this. Let's clear this. And where was our Wolfram alpha? This is it right here. I'm curious as to how intelligent it is. Function 1. Let's make it the green. Let's make it that one. Oh, look at that.
That's fast.
Zoom out. Oh wait, zoom. Sorry, zoom out. Right. Check that out. Zoom in. Now, is that line actually on the graph right there? No. Your calculator will do a similar thing when it changes too quickly. It likes to connect dots. So these are actually just the asymptotes. Does this match our graph? Yeah. Is this a useful tool?
Stops.
Because the resolution isn't very good. The resolution, how many dots it's graphing. It's too steep, essentially. It's too steep. If we zoom in, watch this. Zoom in. Let's zoom in right here. See, it still goes up. Let's zoom out again. Let's pan. So is it still going up here? Absolutely.
But
It is going up. I'm telling you, it's just too steep. It can't handle the steepness.
Huh.
It basically it's rounding. So is it actually stopping? No. Look, if I zoom in here, ready? If I zoom in right here, and I keep on going up, is it still going up?
Oh, it's still going up, but it's just
See?
too,
It's just too steep. Look how close it is.
too
Yeah.
narrow.
So let's reset and let's zoom out. Is this a very, very helpful tool? Yeah, use that. Use that. All right. DIS. DIS. Can you, Covert, can you tell me the domain?
X such that X
Does
does not equal 2, 3, or negative.
not equal what? 2, 3, or what?
-1.
Excellent. Mr. Zung, can you tell me the intercepts?
5, 0,
Mm-hmm.
and -2,
5, 0, and what?
-2.
-2, 0. As well as 0, what?
Wait. 3 over 5.
Hmm?
2 over 5.
2 over 5? When x is 0, what's y?
Yeah. It's 3. Oh, no.
30 over
5,
6 is
5.
5. So those are the 3 intercepts? Okay. Symmetry. Someone else from your group, what do you think? Neither? I agree. Okay, let's go to the back group, group number 2. Who wants to tell me vertical asymptote? Are there any on the back? How many? X equals what? Got it. Excellent. Is there a horizontal asymptote?
Yes.
Yes. What is it? Oh, I'm sorry. I'm skipping here. Removal of discontinuity. I'm sorry. Negative what? Okay. So now we're going to move on. HA. Who has it? Katie? Y equals 1. Exactly. OA. Is there an OA? Nope. And is there a intersect? Where? 1 what?
-4, 1.
-4, 1, yeah. -4, 1. Okay, so let's talk about the homework tonight. First part of your homework is going to be to verify all of the information about R6 that the groups came up with. You understand? So basically do what the other groups did. So there you have the information, just verify that that's true. And also graph R6 by hand. Make sure you know how to do that. I'm getting there. I'm getting there. You really want there to be a video, don't you? You just expect, not really, you just expect one? Okay, the second thing I'd like you to do, play around with all 3 web tools of the day and come in with at least 2 cool facts about each. And last, watch Rational Functions Part 6 and come up with at least 2 questions.
Just when we're on the website, do you have to be